Welcome back to the Metabolic Revolution podcast. I'm Dr. Steve Presciutti, and I am so excited to be here with you today. Last week, we introduced you to the revolutionary science of epigenetics in Season 2, Episode 1. We learned that genes aren't destiny. They're only about 25% of the equation. We talked about the 25-75 split between DNA as hardware and epigenetics as software. We discussed how identical twins age differently based on their environment, not their DNA. And I received so many incredible messages from you after that episode. Hundreds of emails, DMs, comments. The response was overwhelming. You told me this changed everything for you. That for the first time you understood that the phrase, "it's genetic," isn't a life sentence. That you have control. But here's what you also asked me. You said, "Dr. Steve, I get it. Epigenetics is real, but how do I actually change my gene expression? What specific foods? What nutrients? How does this work in practice?" You wanted specifics. You wanted protocols. You wanted to understand the mechanism. Well, today is week 2 of our 6-week extended exploration series on epigenetics. That's right. We're spending the next 6 weeks diving deep into the practical application of epigenetics. And we're starting today with the foundation. Your food is information. I want to introduce you to a concept that changed everything for me. Think about that for a moment. Food isn't just fuel. We've been taught to think of food as energy, calories, macros, carbs, protein, fat, micronutrients, vitamins and minerals. But what if food is actually information? What if every bite you eat is sending messages to your cells? What if breakfast is literally programming your genes? Because here's the truth. Your cells are reading instructions right now. You wrote them with breakfast. Every meal you eat sends signals to your genes through your epigenome, turning pathways on or off, impacting inflammation, immunity, detoxification, and even aging. Food is code. And today, I'm going to teach you how to write better code. This is the Metabolic Revolution podcast from BioSpark Health. I'm Dr. Steve Presciutti, and today we're talking about how nutrients rewrite your genes. This is the information mainstream medicine doesn't want you to understand, because once you understand that food is information, once you understand that you can reprogram your genetic expression with every meal, their entire narrative falls apart. Once you understand that you have control, there's nothing you can do mantra becomes obsolete. So let's dive in. Let me show you why food is code, and more importantly, how to write code that optimizes your genetic expression. So how does food actually rewrite your genes? How do nutrients act as code? It starts with something called methyl donors. These are nutrients that literally donate methyl groups to your DNA. Remember last week when I explained DNA methylation? Those little chemical tags that sit on top of your genes like switches? Methylated genes are turned off. Unmethylated genes are turned on. Well, methyl donors provide the raw materials for those switches. They provide the chemical tags that determine which genes are active and which are silent. Without adequate methyl donors, your cells can't properly methylate DNA. Your gene expression becomes dysregulated. Inflammatory genes get turned on. Protective genes get turned off, and you develop symptoms. Here are the 5 key methyl donors you need every single day. Folate, not folic acid, folate. This is found in fruits and fruit juices, particularly guava, mango, papaya, and oranges. But here's the thing. Most supplements use folic acid, which is synthetic. Your body has to convert it to the active form called 5-methyl tetrahydrofolate. And guess what? About 40% of people have a genetic variation in the MTHFR enzyme that makes this conversion difficult. So you want the active form. You want real food sources. You want leafy greens every single day. The next is vitamin B12, the activator. This works together with folate. You need B12 to activate folate and make it usable. Without B12, folate gets trapped in an inactive form and can't do its job. B12 is found exclusively in animal foods: meat, eggs, dairy, fish. This is why plant-based diets so often lead to methylation problems. Not because there's anything wrong with plants, but because B12 is missing. The third is choline, the unsung hero. This is found in egg yolks and liver, two foods we've been told to avoid for decades. Egg yolks because of cholesterol, liver because, well, I'm not sure why. Maybe because it's, quote, weird? But choline is absolutely critical. Your body can convert choline into betaine, which is another methyl donor. Choline is especially critical during pregnancy for proper neural development. But it's not just for babies, it's for everyone. Next up is methionine, the SAM precursor. This is an amino acid found in protein, meat, fish, eggs, dairy. Your body converts methionine into SAM, S-adenosylmethionine, which is the primary methyl donor in your body. SAM is what actually donates those methyl groups to your DNA. Vitamin B6, the cofactor, found in potatoes, bananas, chickpeas, fish. B6 is a cofactor in the methylation cycle. It helps convert homocysteine back to methionine, keeping the cycle moving. Now here's what most people don't understand. Methylation requires energy. Specifically, it requires ATP. Every time SAM donates a methyl group to DNA, it becomes SAH, S-adenosyl homocysteine. Your body then has to use ATP to convert SAH back to SAM so it can donate another methyl group. So if you have low energy production throughout the body, you are also going to have impaired methylation and impaired gene expression. This is why metabolic health is genetic health. This is why your mitochondria, your cellular energy producers, are directly connected to your epigenetic expression. Let me give you a concrete example. I had a client, Sarah, who came to me with the diagnosis of her thyroid problems being, quote, just genetic. Sarah was 34, running a body temperature of 97.2 degrees Fahrenheit, exhausted all the time, hair falling out, TSH at 6.8. Her endocrinologist had her on Synthroid, but she still felt terrible. The doctor told her, "Some people just have bad thyroids. It's genetic. You'll need medication forever." Her mother had thyroid problems. Her grandmother had thyroid problems. It ran in the family. But Sarah didn't have bad genes. She had bad epigenetic software. So what did we do? We optimized her methyl donor intake. We added 2 to 3 egg yolks daily for choline, ripe fruits and fruit juice for folate, adequate protein from grass-fed beef for methionine and B12. We supported her mitochondrial energy production with traditional fats, butter, ghee, coconut oil, and eliminated seed oils completely. We structured her meals to support circadian cortisol rhythms, carbs, protein, and fat within an hour of waking, lunch as the biggest meal, dinner lighter and earlier. After 6 weeks, her body temperature rose to 98.4 degrees Fahrenheit. Her TSH normalized to 2.1. Her energy transformed. She wasn't just surviving anymore. She was thriving. Was it genetic? Yes. Was it destiny? No. It was epigenetic, and that meant she could change it. The food she ate provided the methyl donors that rewrote her gene expression. The fats she ate provided the ATP that powered methylation. The timing of her meals supported the hormonal rhythms that regulated gene expression. Food is code. Food is literally information for your body about what to do next, and she learned how to write better code. But methyl donors aren't the whole story. There's another class of nutrients that act as epigenetic regulators, compounds that can modify gene expression through multiple pathways beyond just DNA methylation. These are called polyphenols, and they're powerful. For starters, curcumin from turmeric. Curcumin promotes histone acetylation, leading to gene expression activation. Histones are the proteins that DNA wraps around. When histones are acetylated, DNA becomes more accessible. Genes can be expressed more easily. Curcumin has been shown to modulate DNMT activity. That's DNA methyltransferase, the enzyme that adds methyl groups to DNA. It can inhibit excessive methylation of tumor suppressor genes, essentially turning anti-cancer genes back on. research shows curcumin can alter DNA methylation patterns in cancer cells, turning oncogenes off and tumor suppressor genes on. This isn't just theoretical. We're seeing real changes in gene expression. Another polyphenol is resveratrol, from grapes, berries, red wine. Resveratrol activates SIRT1, sirtuin-1, which is an enzyme that deacetylates histones and regulates gene expression related to aging and longevity. SIRT1 activation is associated with improved mitochondrial function, reduced inflammation, and enhanced DNA repair. Resveratrol also influences enzymes involved in DNA methylation and histone modification. It can modulate gene expression through epigenetic mechanisms, particularly in pathways related to inflammation and oxidative stress. Next up is quercetin, from onions, apples, berries. Quercetin can modulate DNA methylation and histone modifications. It's been shown to influence the expression of genes involved in inflammation and cell survival. One study found that quercetin could reverse aberrant DNA methylation patterns in cancer cells, essentially reprogramming them back toward normal gene expression. And last but not least on the list is something called EGCG, from green tea. Epigallocatechin gallate is the most abundant polyphenol in green tea. It can inhibit DNMT activity, preventing excessive DNA methylation. This can reactivate silenced genes, particularly tumor suppressor genes. EGCG has also been shown to modulate histone modifications, influencing gene expression patterns related to cell growth and differentiation. Now here's what's fascinating. These polyphenols work synergistically with methyl donors. Methyl donors provide the raw materials, the methyl groups themselves. Polyphenols regulate the enzymes that add or remove those methyl groups. They work together to optimize gene expression. Think of it like writing software. Methyl donors are the code, the actual programming. Polyphenols are the code editors. They help optimize and refine how that code gets written and executed. Let me give you another client example. Mark was a 45-year-old executive with chronic inflammation, high CRP, joint pain, brain fog. He'd been told he had, quote, inflammatory genes, that it was just his genetic makeup. But we looked at his diet. He was eating a standard inflammatory diet: seed oils, processed foods, very few vegetables, no polyphenols. We added polyphenol-rich foods to his diet: berries every morning, onions and apples in salads, green tea in the afternoon, turmeric in his cooking. We also optimized his methyl donors: egg yolks for choline, leafy greens for folate, quality protein for methionine and B12. After 8 weeks, his CRP dropped from 8.2 to 2.1. His joint pain resolved. His brain fog lifted. Did we change his genes? No. We changed his gene expression. We changed how his genes functioned. Which ones were turned on and which ones were turned off? The inflammatory genes he was born with, we turned them down. The anti-inflammatory genes, we turned them up. Not with drugs, not with expensive treatments, with food, with information coded into every bite. Food is information, it's code, and Mark learned how to write code that turned off inflammation and turned on healing. But here's what most epigenetics researchers miss. You can't have proper epigenetic regulation without energy. Let me say that again. You cannot have proper gene expression without adequate cellular energy. Why? Because DNA methylation requires ATP. Every time SAM donates a methyl group to DNA, it becomes SAH. Your body has to use ATP to convert SAH back to SAM. This is called the methylation cycle, and it's energy intensive. So again, if you have low mitochondrial function resulting in low ATP production, you are going to have impaired methylation, and that is going to lead to impaired gene expression. This is why optimizing mitochondrial function is epigenetic optimization. They're not separate, they're the same thing. Let me explain the connection more deeply. Mitochondria produce ATP. ATP is the energy currency of your cells. Every cellular process requires ATP. from muscle contraction to nerve signaling to DNA methylation. SAMe donates methyl groups. This is how your body adds those epigenetic tags to DNA. Methylation turns off harmful genes. Proper methylation is protective. The cycle requires ATP. After SAMe donates a methyl group, it becomes SAH. Your body must use ATP to convert SAH back to methionine and then to SAMe again. Without adequate ATP, this cycle slows down. Methylation becomes impaired. So again, low energy equals bad or improper gene expression, and that can lead to all kinds of symptoms and disease down the road. When your mitochondria aren't producing enough ATP, your cells can't properly methylate DNA. Inflammatory genes stay turned on. Protective genes stay turned off. You develop symptoms. This is why temperature is such a powerful proxy for epigenetic health. Your body temperature is a direct reflection of your metabolic rate, of your mitochondrial energy production. Higher temperature equals better energy production, equals better methylation, equals better gene expression. I had a client, Jennifer, who came to me with a multitude of symptoms: fatigue, hair loss, cold hands and feet, depression. Her body temperature was averaging 96.8 degrees Fahrenheit. She'd been to numerous doctors, multiple specialists. Every test came back normal. She was told it was all in her head. Maybe depression, maybe anxiety. Here's an antidepressant. But her temperature told the real story, 96.8 degrees Fahrenheit. That's not depression. That's low energy production. That's mitochondrial dysfunction. We didn't start with methyl donors. We started with energy. We optimized her diet for ATP production, adequate carbohydrates to fuel mitochondria, quality protein to provide amino acids, saturated fats, butter, ghee, coconut oil to support mitochondrial membranes. We eliminated PUFA, polyunsaturated fatty acids, from seed oils because they damage mitochondrial function and reduce energy production. We structured her eating to support circadian rhythms. Breakfast with a 2-to-1 ratio of carbs to protein, along with some healthy fat, within an hour of waking. Lunch as the biggest meal. Dinner a little earlier. We added simple movement after meals, 10-minute walks, to improve glucose uptake and mitochondrial efficiency. After 4 weeks, her temperature rose to 98.0 degrees Fahrenheit. Her energy improved. Her mood lifted. Then we added methyl donor optimization, egg yolks, leafy greens, quality protein. After another 4 weeks, her temperature was consistently 98.4 degrees Fahrenheit. Her fatigue resolved. Her hair stopped falling out. Her depression lifted. Was it just the methyl donors? No. Was it just the energy optimization? No. It was both. Because here's the key. You can provide all the methyl donors in the world, but if your cells don't have enough energy to use them, they won't do any good. Jennifer's cells weren't methylating properly because they didn't have the ATP to power the methylation cycle. Once we restored her energy production, her cells could use the methyl donors from her diet to rewrite her gene expression. Again, food is code. But you need energy to run the programming. This is why the bioenergetic approach to health is fundamentally an epigenetic approach. When you optimize mitochondrial function, you're optimizing your body's ability to regulate gene expression. When you raise your body temperature, you're not just improving metabolism, you're improving epigenetic regulation. When you eliminate seed oils and add traditional fats, you're not just reducing inflammation, you're optimizing the energy production required for DNA methylation. Everything is connected. Energy is epigenetics, and epigenetics is energy. So let's make this practical. How do you actually eat to optimize gene expression? Here's your epigenetic meal plan, the code you want to write every single day. Breakfast, the methylation foundation, 2 to 3 egg yolks, richest source of choline, ripe fruit and fruit juice for folate, 1/2 to 1 cup of berries for the polyphenols, 1 cup bone broth or collagen for glycine, which also helps with methylation, and 1 to 2 tablespoons coconut oil or ghee to provide saturated fat for ATP production. Optional, grass-fed beef for additional methionine and B12. This breakfast provides the complete methyl donor package: choline from egg yolks, folate from greens, methionine and B12 from animal protein, polyphenols from berries, saturated fat for ATP production. Lunch, the epigenetic powerhouse: 6 to 8 ounces grass-fed beef or pastured chicken. Provides methionine, B12, choline. Fresh fruit and fruit juice for folate. Colorful vegetables, bell peppers, carrots for the polyphenols. Maybe 1/2 an avocado to provide choline and healthy fats. Roasted root vegetables for additional folate and polyphenols. This lunch continues the methyl donor intake while adding variety in polyphenol sources. The combination of protein, fat, and carbohydrates supports steady energy production throughout the day. And then, dinner, the regenerative meal. Very similar to earlier in the day. You get the point. And the timing of these meals matters just as much as what you eat. Eat within an hour of waking. Breakfast shifts your body from catabolic, breakdown, to anabolic, building. It provides the amino acids and methyl donors needed for the day's methylation cycles. Skipping breakfast deprives your cells of the raw materials they need. Make lunch your biggest meal. Your digestive function and metabolic rate are highest midday. This is when your body can best absorb and utilize nutrients. It's also when your methylation cycles are most active. Keep dinner lighter and earlier. Eating 3 to 4 hours before sleep allows your body to complete digestion before bed. This improves sleep quality, which is critical for epigenetic regulation. Sleep deprivation alone can impair DNA methylation patterns. And again, here's what to avoid. Seed oils, soybean, canola, corn, vegetable oil, they damage mitochondria and reduce ATP production. Processed foods, because they're nutrient poor and often inflammatory. Excessive alcohol. It impairs methylation and depletes methyl donors. Trans fats. These really damage cellular membranes and impair mitochondrial function. Here's the truth. Most people think food is just fuel. Calories in, calories out. Macros and micros. But food is information. Every bite you eat sends messages to your genes. Every meal is an opportunity to reprogram your genetic expression. You're not just eating for energy, you're eating for gene expression. When you choose egg yolks over processed cereal, you're telling your genes to express anti-inflammatory pathways. When you choose leafy greens over refined carbs, you're providing the methyl donors your cells need to regulate gene expression. When you choose berries and colorful vegetables, you're activating polyphenol pathways that modulate how your genes are expressed. Food is code, and you are the programmer. So here's what I want you to do this week. Not next month, not when you have time, this week. Step 1, the methyl donor audit. For 3 days, track your methyl donor intake. Did you eat egg yolks? Choline. Did you eat ripe fruit and fruit juice? Folate. Did you eat quality protein? Methionine, B12. Did you eat foods rich in B6? Potatoes, bananas, fish. Most people are deficient in at least 2 to 3 of these. Identify your gaps. Step 2, the polyphenol add. Add 1 polyphenol-rich food to your diet daily. Berries, blueberries, raspberries, blackberries. Colorful vegetables, bell peppers, carrots. Onions and garlic for quercetin. Green tea for EGCG. Turmeric in cooking for curcumin. Don't overcomplicate it. Pick one. Add it daily. Step 3, the temperature check. Track your body temperature for 5 days. Take it upon waking before getting out of bed. Take it mid-morning. Take it mid-afternoon. What's the average? If it's below 98.0 degrees Fahrenheit, your energy production is compromised. Your epigenetic regulation is impaired. Focus on supporting ATP production, adequate food, traditional fats, regular meals. These 3 steps alone will start shifting your gene expression. Within 2 weeks, you'll notice the difference. More energy, better mood, improved sleep, clearer skin. Because you're not just eating food, you're eating code, and you're starting to write better code. Let me recap what we covered today. Food is code. It's not just fuel. It's information that reprograms your genetic expression in real time. Methyl donors provide the raw materials: folate, B12, choline, methionine, B6. These nutrients donate methyl groups to your DNA, determining which genes are turned on and which are turned off. Polyphenols regulate the process: curcumin, resveratrol, quercetin, EGCG. These compounds modulate the enzymes that add and remove epigenetic tags, optimizing gene expression patterns. ATP powers the methylation cycle. Without adequate cellular energy, your cells can't properly methylate DNA. This is why metabolic optimization is epigenetic optimization. Your meal plan writes the code. Every bite you eat sends signals to your genes. Make those signals count. Now, I mentioned earlier that this is week 2 of our 6-week extended exploration series on epigenetics. Next week, in week 3, we're going to explore the 25-75 truth. What actually controls your health? We'll dive into twin studies and epigenetic divergence, showing you the scientific proof that lifestyle matters more than genetics. You'll see the data that proves environment trumps DNA. Then, in week 4, we'll do a complete methyl donor deep dive: specific dosing, lab testing, optimal food sources, how to assess your methylation status. Week 5 will cover polyphenols and generational patterns, how your grandmother's diet is affecting you today. And week 6 brings it all together with stress protocols, cortisol management, and your complete epigenetic reset system. Because here's the truth. Food is just one type of information your cells receive. Stress is information too. Movement is information. Sleep is information. And right now, most of us are writing code with chronic stress, sedentary living, and sleep deprivation. But you can change that. You have control. If you're ready to stop eating for calories and start eating for your genes, if you're ready to optimize your epigenetic expression and reclaim the health that's yours by birthright, take the Metabolic Health Assessment at biosparkhealth.com. We'll create your personalized epigenetic nutrition protocol, specific foods, timing, and supplements based on your unique biochemistry. Because your genes aren't your destiny, your gene expression is, and that's something you can control. The revolution continues. We're just getting started. If you're ready for some one-to-one coaching to help get things really dialed in, give us a call or reach out on the website. Let's talk.